Hello all, welcome to the new topic of Physics 2, that is electrostatics. Let us understand the overview of the topic. So in this topic we are going to learn about, first part will be always an introduction part. So we are going to learn what electrostatic means, how it differs from current electricity. Electro means electrons and static means stationary. That means electrostatics, it is the study of electric charges which are at rest, which are not moving. Then we will understand what are electric charges. Electric charges are nothing but positive charges or negative charges. There are also neutral charges. So we are going to learn about how these charges are going to behave when they are brought close to each other. That means we already know that opposite charges they attract each other while similar charges they repel each other. The third, we will be understanding the basic properties of electric charge, that how much is the charge possessed by one electron, and how, if suppose we add one electron, then the electric charge is going to increase by what factor. These all things we are going to study under the basic properties of electric charge. We'll be understanding the additive nature of the charge. That means if we add charges to a conductor, that will be added, just like what mass. If I apply 1 kg of mass, then apply 2 kg of mass, then it will become 2 kg. If suppose I supply a 1 coulomb of charge, then again I add 1 coulomb of charge, then it will become 2 coulombs. So that means it is what an additive nature. It can be added. The charges can be added. The second one is quantization of charge. Quantization of charge, that means quantization means discrete nature of the charge. The charge on one electron is 1.6 into 10 raised to power minus 19 coulombs. So if you add 5 electron or if you add 10 electron, then it will be 1.6 into 10 raised to power minus 19 multiplied by 5 multiplied by 10, depending upon the number of charges. So that means the charges are going to increase by certain step, by certain step. Okay. For example, it is what just a two stable. Two ones are two, two twos are four, two twos are four, two threes are six, two fours are eight. So we are increasing the number by two, 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 right? Again, if we add charges, then we are increasing the number by 1.6 into 10 raised to power minus 19 coulomb. Okay, so this we are going to learn in the quantization of charge part. The third part will be conservation of charge. Conservation of charge, that means it is nothing but the conservation of energy. Conservation of energy, that means energy can neither be created nor be destroyed, can be transferred from one form to another form, and the total energy remains constant. So similarly, there is a law of conservation of charge, that charge can neither be created, charge can neither be destroyed, neither be created nor be destroyed. It can be transferred from one body to the another body. And if you consider the total system, the total charge will remain constant. Before transfer and after transfer, the total charge will remain constant. This is we are going to learn in the conservation of charge part. The next is forces between the charges. Forces between the charges. We are going to learn the Coulomb's law. That Coulomb's is the name of a scientist who has given a law to find the forces between the two charges. Now, if there are two charges, two positive charges, then they are going to repel each other. If both are negative charges, they are again going to repel each other. If one is positive, another is negative, they are going to attract each other, and there will be a force of repulsion and attraction. On what factor this force depend on? Okay, we'll be understanding the formulas of this force. So obviously Coulomb's is the name of a scientist who has given us a law of identifying the calculating the forces between the charges. Okay, so the force is equal to 1 upon 4 pi epsilon 0 k q1 q2 divided by r square. This is the formula given by Coulomb. So we are going to learn that formula. Don't worry. The in the Coulomb's law, We are going to first understand the scalar form. Scalar form, that means we are not interested in magnitude. And in the last, we will be getting the vector law. Next, we are going to learn about the relative permittivity or dielectric constant, which is there in the formula. So there's one term called as capital K. That capital K is called as the relative permittivity, or you can say it is called as dielectric constant. So we are going to learn about that thing. Okay. And the third one is the definition of unit of charge. So we'll be defining the charge unit from the Coulomb's law. So we'll be defining the charge unit. So what is the unit charge? It is equal to what is the definition of unit charge we'll be finding from Coulomb's law. Next we will be understanding the Coulomb's law in vector form. The Coulomb's law in vector form. Okay. So first we understood the Coulomb's law in scalar form. In the last part we are going to learn about the direction. So in the direction we'll be understanding that the two charges, if they are similar, then they are going to repel each other, and if they are opposite, then they are going to attract each other. The next part is principle of superposition. Principle of superposition, that means if suppose there is one charge, there is another charge. So there will be a force of attraction or repulsion between these two charges. But if suppose there are n number of charges in the system, then what the value of force it is equal to? If suppose there are n number of charges in the system, then what will be the value of force of one charge, force on one charge due to the remaining charges? So obviously they are going to get added, get added as per the principle of superposition. So we are going to learn about the superposition principle. The next part is electric field. So whenever there is a charge, that means there will be a field. Whenever there is a magnet, then also there is a field, and that field due to magnet is called as magnetic field, and due to charge, if suppose the field is there, that will be called as electric field. So we are going to learn about electric field in detail. We'll be calculating the formula of electric field. We will be defining the electric field. So the first part is electric field due to a point charge in a material medium. So material medium means any medium apart from vacuum. Apart from vacuum, if suppose there is another medium that is called as material medium. The next is the practical way of calculating the electric field. We will be understanding how we can practically get the value of electric field. Next, we'll be understanding the electric lines of forces. They are similar to the magnetic lines of forces that you already aware of. Don't worry, we are again going to understand all the concepts. I will assume that you don't know anything, and I am starting from the scratch. Okay. The seventh part is electric flux. Electric flux is nothing but the combination of electric fields. And the eighth one is the very important thing. These two are very important. The fourth law is very important. The fourth topic is important, and this eighth topic is very, very important. These are the Gauss theorem and Coulomb's theorem. Coulomb's theorem gives you an idea about the amount of force acting between the two charges, while the Gauss law makes us understand about the electric field and relation between the charge and the electric field. So we are going to learn about this Gauss law in detail. The next is electric dipole moment. So electric dipole moment means whenever there are two charges, opposite charges, opposite polarity, that means one charge should be positive, another charge should be negative. And if suppose they are separated by certain distance, then they will be act like a dipole. What do you mean by dipole? Dipole is nothing but electric dipole is same as what magnetic dipole. What are the poles of magnet? Is north pole and south pole. So there is how many poles are there? Two poles are there. So that's why they are called as dipole. Now that dipole, it possesses the properties of magnetic fields. That's why it is called as magnetic dipole. Similarly, as per the magnet, the two opposite charges separated by certain distance, they act same as magnet, but they are not magnet. That's why they are called as electric dipole. There are two poles, and that is called as electric dipole. Okay. So we will be understanding the couple. Couple means so in physics, couple means the two forces which are equal in magnitude but opposite in direction. Couple means what? Two forces equal in magnitude, opposite in direction. So couple means torque. Couple means what? Torque. Couple of forces means what? Torque. What torque will be responsible for? Torque will be responsible for rotational motion. Torque will be responsible for rotational motion. Always couple will be responsible for rotational motion. So couple acting on an electric dipole. So that means an electric dipole is going to rotate in a uniform electric field. Then we'll be understanding the electric intensity at a point due to an electric dipole. And in the last topic, we are going to learn about the continuous charge distribution. Okay, we'll be understanding the linear, the surface, and the volume charge distributions, right? So these are the subtopics that we are going to learn in this session, in this chapter. Okay, so let us start with the first part. NCERT part is not included in physics 2. Only physics 1, there will be an NCERT part. Okay, so let us start with the introduction to this electrostatic chapter. Now, what is electrostatics? What is electrostatics? Electrostatics. So, as the name suggests, electrostatics means there will be an electrons. Static means rest. So, the electrons, so we can say charges at rest. So, electrostatics is what? The study of electric charges which are at rest. The study of electric charges which are at rest is termed as electrostatics. Now, what is the meaning of current electricity? What is current electricity and what is electrostatics? What is the difference between these two? So, we can say the study of electric charges which are in motion. The study of electric charges which are in motion is called as or is termed as current electricity. So that means if suppose this is a charge and this charge plus q, it is now in motion. The charge plus q, it is in motion. That means this study is called as what? Current electricity. The study of charges which are in motion. While if suppose this is plus q charge, plus q1 charge, this is plus q2 charge, this is minus q3 charge. These charges are not at all moving. These charges are at rest. So the study of these charges which are not moving, that is called as electrostatics. Okay. Now, electrostatics is a very important funda because you know that your ATM card, it is made up of one magnetic strip. So there is a magnetic strip in your ATM card. And if suppose you keep on removing and adding that ATM card in your leather purse or leather wallet, then the leather wallet is going to induce the charges, electric charges which are at rest, and they are going to make that magnetic strip corrupt such that your ATM card won't will be able to read the data. Okay, so you have to replace that ATM card. Why this is happening? This is happening because of electrostatics. So we are going to experience a small amount of current by touching the side walls of the refrigerator or while opening or closing the doors of the car, and This is all because of what? Electrostatics. Okay. If suppose you rub your scale on your head and then you attach, you bring near paper, then the paper is going to get attracted by that plastic scale. And why this is happening? This is happening because of the concept of electrostatics. So what is the funda? When is the electric charges are getting transferred from one part to another part? Whenever there is a rub. Whenever there is a rub. So whenever there is a friction, then the electric charges are going to get transferred. This is the concept of electrostatics. And if suppose in the winter season, if you are directly wearing a sweater, then the sweater is going to stick on the skin of your body. Why? Because if you move, the sweater is going to stick on the skin of your body because of the electric charges that get produced between the sweater and your skin, and they are opposite charge and they are going to get attract towards each other. And if you want to remove that sweater, you will be hearing a cracking sound, and that is because of the concepts of electrostatics. Okay, so this is all about the introduction about the electrostatics. Let us move to the next subtopic now. So the next topic that we are going to learn is electric charges. Okay, keep learning, keep smiling. Thank you.